The next step is to adjust the span. Fill the chamber to the upper range value. For this input, the ideal output is 20 milliamps. With the chamber full, turn the span adjustment until 20 milliamps is produced. Drain, then recheck the zero output value. Keep checking and adjusting span and zero until they produce the prescribed output. Finally, check and record the output at the mid-range value. Because of the inherent non-linearity of the torque tube spring, linearity is not adjustable on this type of transmitter. You should, however, record the amount of deviation from ideal. If the mid-range value shows non-linearity, make another zero and span check, and adjust if necessary. Check and adjust the span again, repeating the procedure as necessary. Then, drain the chamber again to the halfway point and do a second mid-range check to verify the calibration. The same sensing principle we've just used to measure liquid-vapor interface can also be used to locate the interface between two liquids. Buoyant force can act on a displacer submerged in two liquids or phases. The heavier of the two liquids exerts more buoyant force, so as the lower phase rises or falls, the displacer travels with it. To create calibration conditions that replicated the process, use liquids that have the same specific gravities as the process fluids. By filling the chamber with the lighter phase, you can check and adjust the zero. In this case, the lighter phase is comparable to vapor in a liquid-vapor interface measurement system. Instead of filling to 90%, it's most efficient with this type of transmitter to fill the chamber to 100% to check zero and span. Once the chamber is full, set the specific gravity. In a liquid-liquid interface application, the specific gravity is the difference between the specific gravities of the light and heavy phase. The specific gravity is set on the calibration plate of the transmitter. With the chamber filled completely with the lighter phase, the expected output is 4 milliamps. If the actual value is different, adjust zero until ideal is reached. Now, to check the span adjustment, you'll fill the chamber completely full of the heavier phase. Adjust span until 20 milliamps output is produced. Once the zero and span are correct, check the output for linearity at mid-range. You'll need to drain out half of the heavy phase, then fill the chamber with light phase. Note any deviation from the expected mid-range output. Then recheck the zero value by draining the heavy phase and filling with the lighter phase. Make any necessary corrections to zero as you go. When the transmitter produces the expected zero output, drain the lighter phase and fill with the heavy phase to check for span error. Again, make any necessary corrections. As you can see, the calibration for a liquid-liquid interface application is very similar to the liquid-vapor application. Checks are made at the low, high, and mid-range values. Again, non-linearity cannot be corrected. However, the values taken at the mid-range should be recorded. In this program, we've seen that flow can be measured using differential pressure. Sometimes a pressure transmitter uses a square root extractor that's located in a separate location in the loop. In this situation, the square root extractor must also be calibrated. When calibrating a flow meter, once the test equipment has been set up properly, a 5-point check is made to determine the instrument's accuracy. Often, special calibrators are used as input standards. We've also seen that, although the test equipment varies according to the instrument under test, zero is always corrected for the low-range value and span for the upper range. Adjustments are made and often readjusted until the instrument is properly calibrated. This training program has been general in nature. The examples given of equipment operation and applications are for illustration purposes only. Always follow manufacturer's specifications and guidelines, as well as your facility procedures when performing instrument calibrations. And remember that safety is your responsibility.